right? So in the last videos, so we are discussing about the double linked list. So how you can able to create a double linked list and how you can able to perform various operations, like how you can able to display the elements. I think size of the list directly we can return. Okay, one second, let me take this example. Yeah, so we have seen traverse function, add first, add last, add position, sorted insertion in ascending order, sorted insertion in descending order we have seen. Now, sir, anyway, that two functions are very easy functions. That's why first let me implement those two functions. What is the two functions? So size or length of the list. How you can able to get length of the list or size of the list? Very simple. You can take return type as integer, get size function I am taking. Okay, what it is going to return? The current object size it is going to return. Okay, next and after that, I want to implement one more function called search. Okay, so I want to implement one more function called search, which will take a data field and it is going to check whether that particular data field is existed or not. Sir, how you can able to check? So we are not required to concentrate on double linked list program. Whatever code we have taken for single linked list, same code. See, where the previous link and the next link you have to concentrate, link establishment we have to do only at the time of creating a new node and at the time of deleting the nodes. Okay, in the remaining cases we are not required to do any alterations. That's why for searching operation, is there any need to remove the data? No. Is there any need to create the data nodes? No. That's why we are not required to go with in detail. Just we can take temp head while this temp is not equal to null. One by one node data we have to check. Sir, if see, it is a search operation, right? That's why if temp tends to data is some temp dot data is equal to data, means what? Our search is successful. Just I am going to return true. If not, if that temporary node data is not equal to this one, then what will happen? As usual, temp will become temp dot next. That's all. At last, what we have to do, sir, return false, which indicates that the search is unsuccessful. Like this we have to take. Okay, just I implemented get size function and then search function. Beyond that, nothing. Let me execute up to this. Anyway, already we have inserted some elements. Now my requirement is I want to get the size of the list dot get size. How many elements are there? 1 2 3 4 5 6 elements are there. My expected answer is 6. Let us execute. You can able to see I have 6 elements are there. Similarly, I want to search for a data. For example, consider I want to search for the element called 666. Is the element 666 is existed? Yes. So hence the output what we are getting is nothing but 2. Is it correct? Yes. So I want to search for 777. Is the 777 data is there? No. Then if you ask the same function by passing 777 as the argument, the output what we are getting is nothing but false, sir. But once if you run the program, you can able to see we got false. So I hope you people got very clear clarity about this, sir. Can you please confirm? Do you have any doubt in this get size and then search functions? Please confirm everyone. Right, sir. So we have completed these two. Now, sir, it's time to talk about deleting from first. I want to delete the elements from first. Similarly, I want to delete the elements from last. Similarly, I want to delete the elements from Yes, specific position. Sir, I don't know what happening. Remaining people, are you people are there or not? Because see, when I'm taking the class, if one or two students are responding, then it is not correct. So only Lingaraj Patil, Vishal, okay, Swapnil, um, Bhuyan, only these people are responding. So remaining people, I think better you can leave the session. There is no need to stay, right? Is it clear for everyone? Please confirm. Right. Now, so the next one, I want to implement deletion of the elements. Sir, I want to delete the items. How you can able to delete? Here you can able to see, I'm going to implement first, delete first. Void, what is the function name? Delete first I am taking. I think here it is not required to receive any parameter. Suppose if your head is equal to null, that means my list is nothing but empty, right? System dot out dot println of I am taking. So double linked list is empty. Then you can return. Suppose if head is not equal to null, size minus minus. Because first node only we have to delete. Now what will be your head? Your head will become head tends to next. Okay, your head will become head tends to next. And compulsory you have to check whether head is not equal to null or not. Suppose if your head is not equal to null, then only you have to set your previous field as null. Listen carefully how it is going to work. Sir, here if you check, I have only one node is there. Okay, only one node is there. This is nothing but the head, and the previous field is null. Next field is null. Then this data is nothing but assume 7. I want to delete from this node, from this list. Is head is equal to null? No. Then size minus minus. Size is already 1. It will be decremented to 0. Now head is equal to head tends to next. What is a head tends to next? Null. Now onwards your head will become null. So it will check if head is not equal to null, but here head is equal to null. Because of this, this statement is not going to execute. Okay. Sir, next, when this line is going to execute, observe carefully. Suppose consider I have a list. Okay, so I have a list. So this is nothing but the data what we have, and this is nothing but the next data what we have. This is null, this is a 2, and this is null. So this one next field is nothing but this one. This one previous field is nothing but this one. This one is null. And this node will become which node, sir? Head node. Now observe carefully. I want to delete first. Is head is equal to null? No, size minus minus. In this case, what is the size? 2 minus minus means 1. Head is equal to head tends to next. Now head is pointing to this particular node. If head is not equal to null, is head is equal to null? No, not equal to null. Then, so head tends to previous will become null. Head tends to previous will become null because anyway this one is gone because this node got deleted. Okay, if you delete this previous field, this one will become null and this one will become null. That's all. Okay, but in the case of single linked list, we are not required to write these two lines of code. This is the extra thing what we have. Okay, so I hope how you can able to perform. So deletion at last, it is very sorry, deletion at first, it is very clear for people, I think so. Can you please confirm, is this concept is clear for you people, guys? Right. So I will go with deletion with last, sir. That means I want to delete the element at last. How you can able to delete? Have a look once. So what is the function name that we have to take? void delete last. Okay, so how you can able to delete? How you can able to delete? Now you can able to see. So delete last means first as usual condition is head is equal to null or not. So if head is equal to null, system dot out dot println of double linked list is empty. Like this I am taking. Then you have to return. Otherwise, if your head dot next is equal to null, okay, if your head dot next is equal to null, that means so this is the last node. Next node is not there. Then we have to delete this node, right? Then immediately your head will become null and then size minus minus and then return. That's all. Otherwise, that means if head is equal to head dot next is not equal to null, head is also null. Not head is also not equal to null. That means we have huge number of elements are there. Then anyway decrement is mandatory. Then to traverse we need some nodes like temp node is equal to, otherwise I will take so temp1 is equal to head. Okay, then temp2 is equal to, I am taking head dot next. Okay, two nodes I am maintaining. So while so temp2, okay, while temp2 next field is not equal to null, sir, what activity we are doing? So temp2 will become temp2 dot next and your temp1 will become temp1 next. Like this we are maintaining 2 pointers. Okay, at last what we have to do, you need to take so temp dot next will become null. That is sufficient, I think so, but we will cross check. If anywhere something happens, then we will go with that previous field method. Okay, now observe carefully. I have some nodes are there here. This is nothing but one, and this next field is nothing but this one, and this next field is nothing but this one, and this next field is nothing but this one, and this field is null, and the previous field is this one, previous field is nothing but this one, previous field is nothing but this one, and this is the head node, right? Like this we have. Okay. Temp1 dot next, correct. Yeah, correct. Good. Now listen carefully what I am going to do now. Sir, here if you observe very clearly, I want to delete the last one. Okay. Here you can able to see, is head is equal to null? No, sir. How many elements are there? 4. Is head is equal to null? No. Is head tends to next is equal to null? Because if head tends to next is equal to null, we have only one node is there. Then we are making head is equal to null size minus minus. Sorry, but next node is there. So hence size minus minus. Anyway, we are going to decrement. Then temp1 is equal to head. This one will become what? Temp1. And temp2 will become this one. Now you got the point, right? So we have to move these locations one by one. Okay, sir, temp2 next is not equal to null. Temp2 next is not equal to null. Yes. Then temp2 will become temp2 tends to next. Then temp1 is equal to temp1 tends to next. Like this we have. This is a temp1, this is a temp2. Since it is a loop, temp2 next is not equal to null. Yes, temp2 next is not equal to null. So move temp2 to here. This will be gone. Okay, and temp1 will become temp1 tends to next. Like this we have. So next temp2 dot next, temp2 next is null. So it will come out from while loop. Very simple. Temp1 dot next is equal to null. Temp1 dot next will become null, so that this field is going to be null. So automatically this will be gone. Sir, remember carefully, we are not required to concentrate on this link, because once if this node itself is deleted, previous is not required because next field is null. Suppose if any such type of situation happened here, then you need to concentrate on previous. Okay, so I think in the case of delete last, previous method never required. But in the case of deletion of first, this node will be deleted. This previous link is there that we have to destroy. When you take the last one, so this previous node is there, but this node itself is going to die. No need to cross check. Okay. Now, sir, deletion at position we have to implement. But before moving to this, can you please confirm? Is it clear, friends, up to this? Clear? Mm. Sir, last node is having link to previous node. How it is going to be garbage collected? See, garbage collector nodes will be there, but when it is going to be happened, I think even if you see this, you can take this node name is nothing but a temp to, right? If you want, you can take a temp to next field, temp to previous field is null. See what I'm explaining. Maybe you are not getting. Okay, no problem. See here. Here, this is the first node what I have. So this first node, previous field anyway null will be there. Next field is pointing here. Okay. For this node, previous is nothing but this one. Next node is nothing but this one. And for this previous node is this one. Next field is null. If you want to delete this particular node, okay, if you want to delete this particular node, so what we have to do? You can delete this node. Okay, you can delete this node. We are making this one as empty. This link will be removed. Okay, so suppose head is equal to head tends to next, like that if you take, so automatically it is going to be moved here. And this previous field compulsory you have to set it as a null because this link is existed, this node is there. Okay, but after this we don't have any, and this is the last. So if you, how this node is referred? By using next to this one. But previous to this node, are you talking? No, because this node is not there. But in this case, previous to node is there or not? Yes, null node you have to take. That's why in this case, deletion of a previous link is mandatory. But here, deletion of a previous link is optional. Even if you take, no problem. But once if this link is gone, no one is going to ask about this node. Yeah, always we are talking about what is the previous to this node, what is the next to this node, that's all. Okay, but in this case, if you delete this node, compulsory this node previous link they are going to ask. In such cases, previous field is important. Clear answer? Not in all cases, only in one or two cases. Okay. Right. T2 tends to data. T2 tends to data. Uh, what is the need for T2's data? See, only for searching operation and only for what you can call insert operation. Okay. In such cases only we required and we need to concentrate on data. In the remaining cases, I think data is not required. T2's data will become 4 only, right? No, we are not required. See, we have to concentrate on our logical parts. So to ensure that node is deleted or not means at the time of printing only we will get, right? At the time of printing, what will happen? So first this will become temp node or current node. So is it next field is not equal to null or not? We will check. Next field is not equal to null means 1. So next it will go to here. So it's data next field. This field is there or not? Yes, print that. Next temp will become here, print that. So next tense is nothing but temp is pointing to null. Then it will stop. Anyway, it will be deleted. Okay. I will show you in the program. Right, sir. At least let me check this delete first, delete last. Is it working perfectly or not? Sir, I am going for add last method. Okay. So by adding triple one. Okay. Next list dot add last of I want to add triple two. Okay. Next. So list dot add last of I need to take a triple three. So list dot add last of I need to take a triple four. So list dot add last of I need to take a triple five, like that we have. So traverse function if you take, then what will happen? It is going to list out all the elements. Now let me check at least the basic. Yes. Now I need to, okay, I need to check system dot out dot println of, I think not required. Directly we can take. So list dot delete first we have to check. Sir, now list dot traverse. So after deleting, what will be the items we are going to check? Now let us check. Sir, what is the first element here? Triple one. That triple one gone or not? Yes. Sir, can I check delete last? What is the last node? Triple five. That is gone. Like this, delete operation is going to work. Sir, okay, fine. What about the next function? The next function what we have here is delete first, delete last is okay. Delete from a position. I want to delete from a specific position. So what is the function name that we have to take? Void delete, okay, delete element. So from position, otherwise at some position. So here I am going to give the position value. You have to check. So as usual, I will take some temporary node which is pointing to head because we need to move to that position. And I will take temp, one more variable temp. Otherwise, let us take it as a temp2 and this one will become temp1. Like this I am taking. Next, what we have to do? Integer. To count that position, we will start from 0. And if temp1 is equal to null, that means what? If head is equal to null, just we have to print because that element is not there, right? Elements are not there. So double linked list is empty. Then we are going to return. Sir, if temp1 is not equal to null, and by mistake, if position is less than 0 or your position value is greater than or equal to get size. Get size. Otherwise, we can call size is there, right? Yes. Then what is the meaning? Sir, we are trying to delete the element which is not having the proper range. I am printing out of range. Then return the program. Else the problem will come. Sir, what is that problem? You have to check whether your position is equal to 0. If a position is equal to 0, we have to do certain job. Sir, what is that job? Your head will become head dot next. That's all right. You are moving head pointer to the next. And we have to check array boss whether head okay, is not equal to null or not. If head is not equal to null, then head dot previous will become null. That means when we have only one node, that will happen, and size minus minus, and we have to return. Sir, it is something like do you know deletion at the beginning? Sir, otherwise what we have to do? We have to move to that particular position. Sir, how we are moving? While your temp dot next is not equal to null and I less than position. So we have to keep on moving, sir. Temp 1 is not equal to null. Then what I am taking here, you have to check one more condition. If I is equal to position minus 1, that means if we have reached to the target, then we need to do certain operations. If it is not reached to target, I plus plus, and your temp 1 will become, so temp 1 dot next. Like this we have keep on moving. I think not required to talk about these things. I will talk concentrate only on this file. Now listen carefully. I am taking the diagram also. Suppose consider I have some elements like this. This will become 11th element, I mean 11, and this will become something like 22. Okay, and this will become something like 33, and this one will become so 44, and this one will become 55. Like this we have, this field is null and this field is null. So this is next, this is the previous, this is next, this is the previous. So this is next, this is previous. Listen carefully, it is somewhat difficult, sir. So 0th position, first position, second position, third position, fourth position. Assume I want to delete the data which is located at third position. Your position value will become 3 here. Now see, what variables we have assigned. Temp1 is always pointing to, temp1 is always pointing to head node, right? Then where temp2 is pointing, temp2 is empty as of, okay. Sir, while temp1 is not, temp1 next field is not equal to null, its next field is not equal to null, okay. I less than position, what is the initial value of I? 0. Is 0 is less than 3? Yes, both the conditions satisfied. And so I is equal to position minus 1, I value is 0. Is it equal to position minus 1? No. Then I plus plus, I will become 1. Okay, I will become 1. Then temp1 is equal to, temp1 tends to next. Like this I am taking. Now again while loop, temp1 next field is not equal to null and I less than position. Yes, true. Then I is equal to position minus 1. No, false. Then I plus plus, now I will become 2. Okay, sir, next what will happen? Temp is equal, temp1 is equal to, temp1 tends to next. Now sir, temp1 next is not equal to null. Yes, temp1 next is not equal to null. Is it I less than position? 2 less than 3. Yes, perfect. Then is I is equal to position minus 1? I value is what? 2. 2 is equal to 2. Yes, that means we came to the exact position. Now sir, we have to break these links and you need to change this link here. How you can able to do that is our main task here. Okay, now sir, temp1 dot next will become, so temp1 next field next, sir. Okay, sir, now listen carefully, I am taking. So if you take this one as a temp1, temp1 next field, temp1 next field is equal to, okay, temp1 next fields next field, temp1 next field will become temp1s to next fields next field. Like this we are taking. Okay, very good, very good. Now the next step what I am taking, listen carefully friends. So temp2 will become, so temp1 dot next. Sir, just now we have seen your temp1, okay, your temp1 next field link we have changed. That means now onwards, temp1 next field will become this one. So that will become temp. So this node is not having any name. That's why I have given the name as a temp. Now getting this previous will become very easy, right? That's why I'm taking this. But make sure, suppose if you want to delete the element which is located at fourth location, please listen my points. If you want to delete the element which is located at fourth location, sir, fourth location next field will become null. On that null you can't call previous. That's why I am writing a small condition. What is that condition, sir? Here your temp2 will become, so temp2, okay, one second. So temp2 will become temp1 dot next. Okay, next field we got. Suppose if that temp2 is not equal to null, then what instruction I am taking? Your temp2 dot previous will become temp1. Suppose if last field is null, then you have to remove this. We can't apply this one. That's all. After doing this, definitely size minus minus and you can return the control. That's all, sir. Sir, will it works or not? We have to cross check. Really, is it going to work or not? Okay. Sir, now what happens is its next field is not equal to null, right? That's why its previous field become this one. And this entire node will be gone. That's all. Because of this one, we got these two instructions. Because of this double linked list, we got these two. Remaining things same, sir. Okay. And this one will become deletion at position. So delete at position is nothing but this one. Can you please confirm? Is this concept is clear for you people? Everyone, please confirm. Right. Let me execute this code. Right. So here dot delete element at a position of 0. In 0th location, which element is there, I want to remove. Have you observed? 111 gone. If you provide 1, sir, what output we are getting? The element located at first location, 222 is gone. Now I want to provide 2. The element which is located at a second location, 333 will be gone. Then I am taking 3. The element which is located at third location, got removed. Now the element which is located at a fourth location, okay, got removed. Sir, can I give 5 here? No, because that position is not there. Sir, in such a case, what will happen? Out of range, because we have written already code, right? Like that it will work. Sir, okay, about deletion from position. Can I delete the element? Can I delete the element? That means what? I have content is there. If we have content, then how we can able to do? Okay, sir, it is also same like previous. Okay, I am taking void delete element of integer data. I am taking next, and after that node I will take some temporary node which is pointing to head, and then I am taking one more temporary variable temp2, and let us it will become temp1. So same like previous code, right? So next what we have to do, if your temp is equal to null, that means what? So list is empty, system dot out dot println of, I am saying double linked list is empty, and then you can return. So temp1, sir, sorry. Next, sir, if temp dot data, that temp1 dot data, that means head node. So head node data is equal to data means the data which you are deleting is available at the first location. Then head will become, so head tends to next. Your head will become head tends to next. Suppose if your head is not equal to null, then what we have to do? You have to set a previous field to null. If it is a head, then we are not required to set, because we will get null pointer exception. Size minus minus and return. This is if the data is available at very beginning location. If the data is not available at the beginning location, then I am taking temp1 dot next is not equal to null. That means the loop which we have taken in the previous case. Okay, while temp1 is not equal to null, this position is not there. Just we have to keep on moving. How many times? If your temp1 dot next fields data is double equal to the data which you want to delete. Okay, suppose if the data is not matched, then temp1 will become, so temp1 dot next, like this we have to, and here I am going to take, so temp1 dot next will become, so already I explained, sir, that's why I'm not giving in detail. Temp1 dot next to next, then so temp2 will become, so temp1 dot next. So if your temp2 is not equal to null, if your temp2 is not equal to null, so temp2 previous field will become, so temp1. That's all. And we have to take a size minus minus and then read. That's all, sir. So beyond that, nothing. So it is going to delete the element. Let me check. Sir, I want to add last. So list dot add last of 666. List dot add last of 777. List dot add last of 888. List dot add last of 999. Like this I have. Okay. Let me give some duplicate elements. So 222, 222. Okay, like this I'm taking. Now delete element at a position. Delete element at a position. Sir, which position? Sorry, delete element. Sir, which element you want to remove? Consider I am taking 666. So is that element is removed or not? Let us cross check. Sir, 666. Previously 666 is there. Now that element got removed. Sir, can I give 222? If you give 222, it will delete the element available only at first occurrence. Rest of the things won't be removed. Why? Because you know very well. So we are going to return. Sir, I want to delete those elements also. In such cases, what we have to do? Sir, same code you need to take. I need to take delete elements. So if delete elements is there, then we should not return. Okay, we should not return. You have to check, there may be a possibility. Okay, and here also we should not return. We have to keep on checking, but at the time of checking, definitely here null pointer exception will come. So you need to write one more condition. Array boss, if temp1 next field is not equal to null, then only you have to move temp1 is equal to temp1 tends to next. Okay, only this modification. Now let us run. Really, is it going to delete? Only first occurrence got deleted. I think function name I have not changed. Now, sir, is it deleting all the occurrences? Yes, here 222 gone, 222 gone, 222 gone, like that. This is nothing but how you can able to perform. So deletion of element at first location, last location, position, deleting the elements, and deleting the element, and deleting the elements. Okay, so I hope you people got very clear clarity about this. Can you please confirm, friends? Do you have any doubts up to this? Right. That's all about today's session, sir. Tomorrow maximum we will finish this, because reversing the list and deleting duplicates, copy the reversed list, this will become same. Okay, we will complete tomorrow double linked list. Okay, right, sir. Thank you. I will upload the running notes after 9 o'clock. Okay, right. Thank you.